All right, Dijkstra's algorithm is when I want to find the shortest distance, the shortest path between two given points. And this one is trickier because often the shortest path isn't going to start with the shortest edge. And so when I use Dijkstra's algorithm, I'm going to keep track in a table. And your book gives a different method. And so you might want to look at your book's method, and I'm going to show you this method. So for every point, we're going to create a table next to the point. And I like to draw my table this way. So in this box here, I'm going to write the order that it's labeled. And in this box here, I'm going to write my distance from the start. So distance from the start. And this box here, I'm going to write the vertex that I came from. And these are all going to be my permanent labels. So I only find these after I've found my shortest distance of my temporary label. So this is my shortest distance so far. And this is going to be an ongoing list. And it's temporary. So it's easier to explain when we have an example. So I'm going to look at an example, at example 3 here. So we want to apply Dijkstra's algorithm to this drawing, going from S to T. So, all right, I want to go from S to T. So first of all, I'm going to start by only looking at S. So I want to, I'm actually going to come down here where I have this drawn. All right, so looking only at S, then I can start with S, and this is going to be my starting vertex. So coming off of this, I can start off my label. My distance from S is 0. This is my first label, has a distance of 0. I came from nowhere. And now, for my next set, going from S, I can go to A, B, or C. And I can see here, because this is my start, my next one is going to be to A, because that has my distance of 3. So coming into A, so far, this is my shortest, so I've got my distance of 3. And because it's my shortest, I'm picking it permanently as my second label. The distance from the start is 3, and I came from S. Okay, from A, I can come over here to T, and now in my box, my temporary distance is going to be 14, because I had 3 and 11. I could come down to B, and in my box, I've got a temporary distance so far of 3 to 4 makes 7. I could, so that's A. From S, though, we also had our initial ones, so down to C is 4. So this distance is 4. So looking around at what I have so far, I've got the second one's already labeled with its permanent labels, so I don't look at that anymore. And now I'm looking for my smallest number, from B, if we had drawn that originally as well, because originally we could have gone from S to B. So let's actually put that in as 6. And now we could also get to B by going from the 3 to 4, which is 7. I'm going to exclude the 7 because it's a bigger number. We always want our smallest distance possible. So right now, the smallest distance that I see from 14, 6, and 4 is, of course, 4. So I'm going to take the 4. That has a label of 3. It has a distance of 4. And it comes from point S. For my next one, I'm going to draw in my next set of vertices after C. And so I'm going to come up to B. That has a length there of 1. So 4 and 1 makes 5. So I'm going to cross out my 6 and add in a 5. Okay, I can also go from C over to D. And here's D. This has a length of 4. So adding a table for D. Getting to this, 4 and 4 is 8, over to the D. And I can see now that my smallest number is 5, so I'm going to make this my permanent one. So it's going to get the 4th label. It has a distance from the start as 5, and I came from point C to get there. Okay, now I'm going to add in my from point B, the places I can go. So from point B, I can go down to D, and going down to D has a length of 2. So that means from my start then, I would have my length of 2 down to D. Oh, I also had my 4 and 4. Okay, so to get to D coming this way with what I just drew, I would have my 4, 1, 2 makes 7. So now I have 7. And remember, we did the 4, 1 because that was how we got to the 5. So 4, 1, 2 makes 7. I also have from B coming out to T, having this path is 8 here. So 4, 1, 8. Now I need a box for my T. So that has a distance of 13. Okay, so I'm going to take my smallest number so far, and that is going to be the 7. So, and remember, this is my distance from the start. So since I have 7 as my smallest distance from the start, that's the one I'm going to take. So I'm up to vertex 5. My distance is 7. And to get to here, I came from B. Okay, so now I'm going to draw in my remaining line, which is a 5. So this one comes through. This is this line here of 5. And so now from coming from D up to here, I had a distance of 7. I add 5 and I get 12. So that is my shortest distance. So I'm going to take that one. This is my 6th label. I came from vertex D, and my distance is 12. So the length of the shortest path is 12. Working backwards from T to see how I got there. So T to D. From D, I came from B. From B, I came from C. And from C, I came from S. So the shortest distance is to go SC, CB, BD, DT. And that gives me my shortest distance of 12. And that is Dijkstra's algorithm.